I have bring down the table dito, no? So, this is table ng components of your dry air. So, we have your oxygen. So, usually our dry air is composed of our oxygen, okay? We have your nitrogen. So, carbon dioxide. We have hydrogen, argon. Okay, so these are the traces of gases na not mostly being used in the stoichiometric. Mapapansin nyo, in terms of volume ratio, so we have yung mga malalaki that mostly na ginagamit is we have your oxygen. Okay, so mataas ang percentage niya in terms of volumetric analysis, in terms of volume. And also we have your nitrogen, and sumunod is we have your carbon dioxide, and then also your argon. So that's why yung mostly ginagamit lang palagi is our oxygen and nitrogen. Since the rest of traces of other gases are not being used in the stoichiometric analysis. And also in terms of your molecular mass, so mataas pa rin ang oxygen and also yung nitrogen. So that's why it is commonly being used in terms of stoichiometric analysis compared to the other gases, which is already being maliit na siyang ang value. So that's why it's being disregard na lang in terms of computation. Then we have here the methods, no? I have here the methods that will be used natin later on for the solving of our air fuel ratio. So first we have we have two types, no? A priori analysis and a posteriori analysis. So for the number one, priori analysis, so that will be computations are made theoretically before that combustion takes place. Okay, so before mag-start yung combustion, so we compute it so that is what called the priori analysis. Then next we have the posteriori analysis. So posteriori analysis were based on the actual data that is after the combustion takes place. So this is already from the product of combustion. So we take already the samples of the product, then from there we analyze what type of air fuel ratios will be used in the combustion. Now, for step 2, so we're going to write out the molar equation. So we'll balance the equation by balancing, so using the principle of mass of conservation. Okay, so going back, that is from your thermodynamics 1, no? So let's start to balance. Let's start with the carbon. So to have to compute the molecular weight, no? So we have 16 doon. So then the carbon has an atomic mass of, so we have for carbon the molecules is 16. Okay, so we have the molecules na ito. So we have 16. So multiply yung value here, that will be 1. So that will be, so since wala tayong given dito, so we have mass. No? Then it is equate sa our product, so that will be B. So since 1 din ng molecules nito, so we're gonna multiply this 1 by 1. Then we have the value of 16 for the value of B. Then let's go for the hydrogen. For hydrogen naman, no? So what we have there is 32 times 1, which is equal to the fuel doon sa kabila for the product. So we have 2. So ito yung mga kasi yung B, C, and A were the unknown values. So we have 32 times 1. Then sa kabila, we have That will be 2 times C. Okay, then your C, 32 divided by 2, so we have 16. Okay, so ganun naman siya. Hindi naman siya complicated. Then we have your oxygen. Okay, so that will be O2. Okay, so that will be 2 times A sa air natin. So that will be 2 times A. Then sa kabila, we have 2 times B. Then, ano pa meron? So we have here C. Okay. So since given na ang B at ang C, so we can compute the value of A. So substituting yung value niyan, we have your A is equal to 2 times the value of B, which is 16. Then add natin yung 16, no? So we have the value of A is equals now to, this is 2. Kalimutan natin 2. So divide that 1. So we have 24 for the value. Okay. So that will be the value of A, which is 24 now. No? Then next, what we are going to do is substitute this one to rewrite our stoichiometric formula. I forgot to add, no. So in balancing, okay, so I'm going to write that one. Now in balancing, so we need to assume we need to assume by starting 1 mole of fuel that will be used doon. So that's why dito we use that one value here. So we are trying to assume 1 mole of fuel. So later on, kung how many volume man yan or mass ng fuel. So later on, in the estimated air fuel ratio, so pwede natin doon i-multiply yan. Okay, now we try to rewrite our equation. So from galing dito, so we have, okay, rewriting that one. So rewriting natin yung kanina. So pinaste ko na lang dyan, no? So by substituting yung values natin, yung nakuha natin dito previously, so substituting that one to combustion formula. So we have C16, okay, that will be H32 plus yung A. So what will be the value of A? So we have 24. So we have your 24, we have your oxygen plus 3.76. So that will be your nitrogen. Then punta doon sa product. So ang value ng B, so that will be 16. So we have 16, then CO2 plus the value of C, which is value of C is 16 also. 16, we have H2O, then plus your A, okay, we have your 24, then multiply by 3.76. Okay, so they have your nitrogen. So mapapansin nyo dyan, we have H2O to the product of combustion. So yung mga product of combustion is a mixture of CO2, okay, then H2O, and we have the nitrogen. Now, if I'm going to completely expand yung equation, so we have C16H32 plus that will be 24 of oxygen plus 24 times 3.76, so we have 90.24. So this will be your nitrogen. Then we have 16, so that will be CO2 plus again 16 H2O plus this one 24 times 3.76, we have 90.724. Sorry, that will be 90.24. 24. So for your nitrogen. Okay, so this is now our product ng combustion, no? Okay. Then now for step 3, so we're going to compute the stoichiometric ideal or theoretical air fuel ratio. So I'm gonna write here. So this is stoichiometric. So I'm gonna put here S. So para later on we don't have a confusion on this one. Now for the equation of our stoichiometric, no, air fuel ratio. So that will be the equation of mass of air divided by the mass of fuel, or that will be your equal to the moles of air multiplied by the molecular weight of air, or moles and divided by then divided by the moles of fuel multiplied by the molecular weight of fuel. Okay. So for the moles of air and molecular weight of air, so referring on this one, okay. So yung air natin, so ito yon. Okay, yung part na ito. So this is your air. Okay, let's mark that one. And this is our fuel. Okay. So moles of air we have dyan is 24, no? Then your oxygen, so that will be 16, no? Yung ano niya, atomic weight niya times 2 for the molecules niya. Okay? So kaya naging 16. So that will be 24 times 16. That will be times 2. Okay? So that is the molecules, then multiply by the molecular weight, okay, and times your moles. Okay. Then last, we have the moles of your nitrogen, that will be 90.24 times 2. So nitrogen, the we called it molecular molecular weight. So that will be 28 for the nitrogen. Then divided by the mass of fuel. So we have your fuel, that is hexadecadency 16H32. So that will be 16. Okay. So take note, kanina we have in balancing, start by assuming 1 mole of fuel. So ang mole of fuel na natin that will be used here is 1 only. So I'm gonna multiply it all by means of 1. So we have 16. Okay, the molecular weight, the molecules times the molecular weight. So that will be 16 times 12. Then plus natin, that will be 32 times 1 molecules times molecular weight of hydrogen, that will be 1. So that will be 1 times your 32. Okay. So finally, using our calculator, so yung value na ito, so we have 14.7. So take note, ang unit will be kilogram of air divided by the kilogram of fuel. So yun ang magiging units niya. So every time that will be, what will be the tatanungin sa problem, so units ng air fuel ratio is in terms of kilogram of air and kilogram of fuel. So this is for liquid fuels only. So later on we'll be discussing what will be pag gaseous and also pag solid fuels na. So kasi meron tayong gaseous fuels katulad ng mga methane, other pa mga other fuels pa. So mostly kasi yung common is methane. Also yung ano natin, no, yung LPG, so that is also in the form of gas. And for solid naman, mostly ang kilala in industry is yung coal. Okay? So later on, makakarating tayo doon to discuss that one. So, okay, so let's have a recap nung ano natin ng stoichiometric. Okay, so let's have an overview of our solutions. So starting, okay. So first, okay, so first, for theory analysis, so start with the combustion formula. So we have the ano ng fuel plus your air, then you have your products. Then we have the standard formula. So ito na yan, paulit-ulit na lang yan in terms of liquid fuels, except liquid fuels only. So we have the air and we have your fuel. Then this is your product of combustion na ito. Then we do mass balance. Okay. So mass balance of the molecules, and so we're going to assume 1 mole dito of your fuel. Okay. So makakuha natin ng value ng B, then value of C on the other side. Then finally, for the oxygen, so we can get the value of UA. Then, so kung ano natin yung value, then we can substitute to the combustion formula. Then, okay, so we can expand the equation. Then finally, we have this one for the final answer of your combustion formula. Then, now for the required stoichiometric air-fuel ratio, so we have the mass of air and mass of fuel, which is equal now to the moles of air multiplied by molecular weight of air, and divided by the moles of fuel and molecular weight of fuel. So we substitute the value. So take note, so palagi pag liquid fuel, so yung moles of fuel natin, so we will always be assuming 1 mole lang palagi. Okay? So proceed to the next video so we can discuss for the gaseous fuel or later on. So it's okay, so proceed to the next video. Okay, thank you.